There are 5 basic types of chemical reaction, namely synthesis, decomposition, single replacement, double replacement, and combustion. Okay, in synthesis reaction, 2 or more reactants combine to form one new product, designated with this general equation A plus B to form AB. It is similar with when two substances are at the chemistry prom, dancing alone, and they decide to hook up. Okay, so they form one couple. So example of synthesis reaction showing one product is reaction between sodium and chlorine gas, forming one product, sodium chloride. Notice that this is unbalanced reaction because we will discuss balancing chemical reaction in our next video. So next is decomposition reaction. One reactant breaks down into 2 or more products. So similar again in a chemistry prom, a couple dancing together, they decides to break up. So we have one reactant decomposed into its components. There. Now, one example of decomposition reaction showing one reactant is the decomposition of potassium chlorate. Potassium chlorate decomposes to potassium chloride and oxygen gas. So take note, it is the opposite of synthesis. We have one reactant breaks down to 2 products. And take note, this is also unbalanced reaction. Another reaction type is single replacement. So from the word single, it means one replacement. In a single replacement reaction, one element or ion is swapped for a similar element or ion. In the reactant side, we have 2 reactants, and on the product side, we also have 2 products. But one is single. So for example, we have this scenario. Okay, we have the reactants. We have a couple here and a single lady here. And then this couple breaks up. And then we have a new partner, a new couple, and we have a new single product. So why did it happen? There are lots of ladies out there. Why could Angelina be the one to break up Brad and Jen? So this was no replacement. So there is no reaction. There was no replacement. But this one, the second one, has reaction. There was a replacement. So why? Who is most attractive? Oh, reactive. So the most reactive is the one that replaces the one from the couple, original couple, and this one has no reaction, is the least reactive. So similarly in chemistry, we have what we call reactivity series of metals. It is a series where the one on top can replace the one below. So let's have these examples. Will there be a reaction? Can iron replace copper? Yes. Iron is above copper. See, iron here is above copper. So there is a reaction producing iron sulfate and releasing copper. So the one that is released is the lesser active. Okay, next we have nickel plus sodium chloride, no reaction. Okay, why? You see, nickel in the activity series is below sodium. So here is nickel and here is Na. So nickel cannot replace sodium, right? It cannot. So what about lithium here? Can it replace zinc? Yes, it can replace because lithium is on top of on top of zinc, right? Okay. So what happened to zinc? The lesser reactive is released. So the one that is lesser reactive is released. Now we have copper plus aluminum chloride here. Can copper replace aluminum? No, because copper here is below aluminum here. So there is no reaction. No. So this is it. Metals near the top, look, metals near the top are most reactive and can displace metals near the bottom, but not the other way around. Likewise, we have reactivity of halogens. The same goes for halogens. More active halogens replaces the less active halogens. So which halogen is most reactive? Fluorine can replace bromine. Iodine cannot replace chlorine. We have the activity series here. And as you can see, chlorine is on top of bromine. Yeah, it can replace. And iodine is below chlorine. It cannot replace. So that is why there is no reaction here. Okay, the fourth type of chemical reaction is what we call double replacement reaction. And it involves exchange of partners. So we have, always remember, in a compound, the one on the left is positively charged and the one on the right is negatively charged. And there will be a switching of ions. So as you notice, the products, you have the X switch with Y, and so we have the product AY, and B has now partner with X. So there is an exchange of ion partners. So the two ionic compounds swap ions to make new pairings. So we have, like here, we have Joe and Angie and Chris and Anna. So Angie will exchange with Anna. So that is why we have new partner. The new partner of Joe here is Anna. And the new partner of Chris is Angie. So AX plus BY will produce AY plus BX. That is the general equation. So let's have an example. There. Who is similar? Okay, so we have magnesium is similar with calcium. Both of them are metals. So that is why there is a double replacement. sulfur now will exchange partner with oxygen, and oxygen now is with calcium, and sulfur now is with magnesium. So metals swap with metals, and non-metals swap with non-metals. Okay, the fifth type is what we call combustion reaction. Combustion is like burning, and it is the burning of hydrocarbons with oxygen. So the general equation, this is the formula of hydrocarbon, and of course this is the formula of oxygen gas. And take note, the products are always carbon dioxide and water plus the release of tremendous heat. So example, we have methane gas, the one in our liquid petroleum tanks, the one we use for cooking food. So there is a reaction, combustion, oxygen with methane, producing carbon dioxide and water, and the products is heat, the one that we use for cooking our food. And we call it exothermic reaction because heat is released.